The Tsing Ma Bridge, part of the Lantau Link, was officially opened by Lady Thatcher on the 27th of April 1997. The Lantau Link project was started in 1992 as one of Hong Kong's 10 massive infrastructure projects costing approximately 1.8 billion US dollars. Consisting of a suspension bridge, a cable-stayed bridge and a viaduct, the Lantau Link is the vital connection between the new Chek Lap Kok Airport and the urban areas. The Tsing Ma Bridge, connecting the islands of Tsing Yi and Ma Wan, will be the longest road and rail suspension bridge in the world. With a span of 1,377 meters, it will carry 6 lanes of traffic on its upper deck and 2 rail tracks on the lower deck. As the bridge will be the only highway and railway link to Lantau, the designers made certain it would first provide free access under all weather conditions, second, be protected against collisions by ships, and third, be stable during high winds. Traffic will normally make use of the top deck, but under severe weather conditions, the bottom deck inside the box would be used. Second, the bridge will be protected against possible ship impact. This is why the Tsing Yi Tower has been placed on land, and why the Ma Wan Tower has been located in shallow water surrounded by an artificial island. Third, the bridge has been designed to withstand the very high wind speeds experienced during typhoons. To make certain of this, extensive wind tunnel tests were carried out both in Canada and the UK. Work began in May of 1992, and with its scheduled completion date of May 1997, the project will take 5 years to finish. To construct the bridge, the Highways Department of the Hong Kong government selected an international group of contractors who have built some of the longest and largest bridges in the world. The total value of the contract was 900 million US dollars. Initially, the work involved an enormous amount of excavation below ground level on small, steep and congested slopes at each landfall. The largest excavations were for the 2 anchorages, which will restrain the load of the bridge's suspension cables. On Tsing Yi, a massive excavation 55 meters deep was carried out. At Ma Wan, the anchorage was partly underground and partly above ground. Below ground, the excavation went to a depth of 20 meters. Work has already begun on placing the basement and walls of both anchorages, which will eventually be filled with concrete. The Tsing Ma Tower is on a spread foundation. Each leg of this tower is supported by a reinforced concrete footing 27 meters long, 19 meters wide and 7 meters deep, which rests firmly on solid rock. In the footing, all reinforcing steel bars have been exposé coated to give additional protection from the marine environment. Two huge concrete caissons, which will become part of the foundation for the Ma Wan Tower, were cast on the deck of a submergible barge anchored near Tsing Ma. Both are 28 meters long, 20 meters wide, with one 17 meters high and the other 19 meters high. The Ma Wan Tower foundation is located in shallow water of about 12 meters deep. Preparation work of the foundation included underwater blasting to flatten the area on which the caissons will rest. When the Ma Wan site was ready, the two caissons on the barge were towed to a site off North Lantau. After sinking the barge by adding water, the caissons were floated off. They were then towed to the Ma Wan site. At Ma Wan, the caissons were positioned and aligned properly. To protect the tower from ship impact, rock and selected fill material was placed around the foundation of the towers to form an artificial island of an area about 4 hectares. The most prominent feature of the Tsing Ma Bridge will be its twin towers, each of which will stand at a height of 206 meters. These towers are made of high-grade concrete, which is batched in 2 computer-controlled plants on site. Using this concrete will make the towers capable of withstanding the most severe weather conditions. The construction of the towers was completed in a period of only 3 months. This was made possible by concrete slip forming.
That's a technique whereby you use steel formwork 1 to 1.5 meters high, and the concrete is placed inside and vibrated, and by the time the slip form moves vertically, climbing itself on jack rods cast into the concrete will be hardened or stiffened at the underside of the formwork.
To ensure the tower's stability, particularly in high winds, portal trusses cast in concrete were installed between each leg. The next step is to prepare the top of the towers for the installation of the large steel saddles that will support the main suspension cables of the bridge. A saddle is composed of 3 pieces. Each piece of approximately 130 tons was lifted up to the top of the tower by strand jacking technique. Once at the top, each piece is aligned and then bolted together. In order to ensure the Tsing Ma Bridge is constructed on time and within budget, the staff of the Highways Department administers the project closely and normally holds regular meetings with consultants and contractors to monitor the construction progress. The international nature of the bridge extends not only to the engineering expertise involved, but also to the structure itself. In Japan, Manufacturing and fabrication of the structural components, such as the trough and plate girders for the deck units, are being carried out. A large steel plate is first manufactured by hot rolling. Then it's flame cut into pieces with approximate dimensions for deck trough and plate girder fabrication. The deck trough is formed by upside-down welding of the trough to the deck plate by 6 heads welding simultaneously. This is the fabrication yard in Japan. Similar work is also being done in the UK, as well as machining of the cable saddles and their supporting grillages. A trial cable compaction for the 1.1 meter diameter main suspension cable was carried out. A trial assembly of a half section of a complete deck unit was carried out before the components are transported to the final assembly area in China. The off-site work also includes China, where sub-assembly deck units are being assembled in a 400,000 square meters yard. This assembly process includes grinding of welded joints, washing and painting of sub-assembly units, checking plate thickness, assembly of outer truss unit, sample testing of weld strength and assembly of sub-assembly units. In order to ensure the aerodynamic stability of the bridge under construction, extensive wind tunnel tests have been carried out in both the United Kingdom and Canada. In Canada, a full aeroelastic model of the entire bridge was tested by simulating topographic effects during the different stages of the bridge's deck construction period. Once the saddles were installed, the spinning of cables was about to begin. The cables were constructed by the aerial spinning process. The aerial spinning process involved drawing wires from a constant tension supply and pulling loops of these wires from one anchorage to the other.
In the morning on the last day of March 1994, the first cable was in place.
Before this could be commenced, it was necessary to construct temporary footbridges from anchorage to anchorage along the line of each cable. Working platforms known as catwalks were suspended a meter below the cable positions to enable the workers to form the cables above the Marwan channel. This aerial spinning technique dates back more than a century, but this was the first time it has been used in Hong Kong. On a system of pulleys, 4 loops of steel wires were drawn from the Marwan anchorage through the saddles, over the tower tops, all the way to Tsing Ma anchorage. For convenience of spinning and adjustment, The cables are divided into 91 strands of 368 wires. The process was repeated more than 8,000 times to form each cable of some 34,000 wires. The cables took 9 months to complete and support the entire bridge's weight of over 50,000 tons. Following the completion of spinning, each cable was compacted into a circular shape and bound with temporary strapping. The cable bands were then fitted, clamped into position by tightening the large high-strength bolts. The suspenders were then looped over them. Each cable measures 1.1 meters in diameter, and the combined length of the steel wires adds up to 160,000 meters, enough to circle the Earth 4 times. The next stage is to hang suspenders from the suspension cables so that they are ready to receive the bridge deck units. Transporting the assembled deck sections to Hong Kong proved to be a mammoth task. Damage to any part of the assembly from strong winds would have held up the entire process. A specially designed barge was built to transport 2 deck sections at a time from the assembly yard to the bridge site. It was in the early hours of the morning of the 9th of August 1995 that the first deck of the bridge arrived from Dongguan. The barge was moored directly beneath the bridge, and the deck sections lifted into their final position by lifting gantries standing on the main cables. The first deck section took 6 hours to install. The bridge is made up of 95 deck sections, each weighing 500 tons. It took 9 months to lift all deck sections from the barges on the channel. On the 28th of March 1996, the final deck section was lifted and the bridge was in sight. The suspension cables were finally painted and wrapped. The purpose of the wrapping is to enclose the cable in a weatherproof sheath in order to protect and preserve the galvanized wires of the main cables. The rail tracks were laid. They were then leveled and fixed on beams supported by rubber pads. From the air, we could see the entire fixed crossing from Tsing to Lantau taking shape. Yet there was still a lot to be done before the opening. Since Hong Kong lives under the threat of typhoons every summer, and there's traffic on both decks, as well as a high-speed railway on the lower deck, the bridge must withstand high winds, considerable weight, and vibration. Therefore, a well-designed bridge monitoring system is devised to monitor the structural performance of the bridges under various combinations of wind, temperature, and traffic loads. Over the last year of construction, nearly 600 sensors were installed on the towers, cables, lower and upper deck units of Tsing Ma and Mun Bridge. These 600 sensors include anemometers, accelerometers, temperature sensors, displacement transducers, strain gauges, leveling sensors, and weigh-in motion sensors.